In this video, we're going to continue with marginal treatment effects, and a key ingredient to understanding what marginal treatment effects are all about and why it's so useful to study them is heterogeneous treatment effects. Now, to recap what we've done in the previous video, we've looked at Heckman's two-step selection model, and we have seen that there is a way to solve the problem of selection bias by accounting for selection into treatment through parametric assumptions. That was the great insight from Heckman's model. But Heckman's model was based on homogeneous treatment effects. The idea was that anyone, if they're given the treatment, the gain in the outcome is the same, but there is heterogeneity in the costs of people getting the treatment. So for some people, getting the treatment is more costly than for others. However, what we usually have is that the treatment effects themselves are heterogeneous across people. If you give some people a treatment such as free childcare, a free pass to a gym, a voucher to move to a better neighborhood, or whatever that treatment might be, some people will find this more beneficial than others. And on some people, it will have a measurably better or stronger effect on whatever outcome we're interested in than on others. That's what heterogeneous treatment effects are. And now when we take all these things together, so people select into treatment because they weigh the gains from taking the treatment against the costs of taking the treatment. And if the gains they get then in terms of the outcome from the treatment are different across people, we have a lot of heterogeneity that we need to deal with. So if we want to understand the causal effect of a policy measure, we need to understand how to take this heterogeneity into account. So far with the Heckman selection model, we've looked at one dimension of heterogeneity. Now we'll add a second one and see how we get on. You will see it's actually, once you understood the challenge of heterogeneity in the Heckman model and the solution via truncated normal distributions, that's actually half the battle here. Now again, why are we doing this? Why are we looking at marginal treatment effects in the first place? We're looking at it because typically what we want to study is we want to study the causal effect of some policy. Whether we're working for a government or for a company, typically what economists do when they do empirical work is they want to study what is the effect of a new policy in the company, a new marketing measure or whatever it is, incentives provided to customers on then some measurable outcome, whatever that is, customer behavior and so on. The same goes for obviously for public policy. But in doing so, when doing that, we obviously need to think carefully about, well, what is the population that we're actually interested in? And there is a huge discrepancy between what even an experiment where we can perfectly control things, even in that experiment, there is a discrepancy between what the experiment can identify and to what extent and the target parameter that I actually want to know for the population I care about. Okay? The example was that if you have imperfect compliance, even if the assignment of the instrument or of the treatment itself is random and therefore exogenous, people taking up the treatment or not is not exogenous. And so therefore, what we identify is a local average treatment effect, yet that local average treatment effect is only informative for those people whose behavior has been changed by the assignment of the treatment and not for anyone else. Yet that anyone else may well include people that as policy advisors or as consultants we're actually interested in. And to put those two things together, what we can identify and what we want to identify, we need the framework of marginal treatment effects. So the point here at the bottom is very important and tends to be often forgotten, especially among empirical economists who do mainly academic work, is just because an effect is causal doesn't mean it's interesting or relevant for anyone. Right? You have to really think, well, what is the broad application of my results? To whom do they apply? And so we need to take a stand on that. And so we need to have an ultimate target parameter in mind. The target parameter could be something like the average effect of free childcare on female labor supply among women between 20 and 40. That could be the target parameter, just as an example. And then I need to think, well, with the instrument I have in hand, to what extent can I actually provide some informative analysis about that target parameter? And so here is where heterogeneous treatment effects come in as one of the challenges here, but also one of the ways to make the econometric analysis a lot more realistic. Right? So here, in most cases, the returns to treatment, they vary in the population. So think about job training programs. Whether you give a job training program of the types that most countries have, whether you give that to people who are completely untrained or to people who've gotten unemployed from a high-profile job, probably the job training program will have a different effect on the re-employment probability of these types of workers. Or if you give a job training program to older workers, that may actually have a greater effect than if you give it to younger workers, because younger workers may have more options anyway, and so a job training program may not make such a big difference to them, or vice versa. Right? So I don't want to really say, the effect here goes in one direction or another, but the fact of the matter is that it's most likely different between different groups in the population. And so when we put these heterogeneous returns to treatment together with the fact that people can select into the treatment, either because they can genuinely select into the treatment, or because they were randomly assigned the treatment but then have to decide whether to take it up or not, then we obviously have a situation where we need to clearly understand how those heterogeneous effects are related to selection into treatment. And ultimately, when that's the case, what the estimate that we're getting from running whatever econometric model we're running, to what extent that model, that estimate corresponds to the target parameter for the population we're interested in. And an important step along this way is a model from the 80s by Bjerklund and Moffitt, which is a very straightforward extension to the Heckman two-step selection model. So what they do is, very simply, they incorporate heterogeneous treatment effects into an otherwise standard selection model. And then in an empirical application, use it to look at all sorts of effects of, for example, unionization on wages, of education on wages, and so on. So the main part of the paper is the method, and then they show an application based on Swedish data. So what does the model look like? It's similar to what you've seen before. So you have the main equation that relates that basically determines the outcome. So we have the outcome y, which is a function of some observable characteristics, as well as the treatment, as well as the unobservable characteristics. And we can again assume that there is a correlation between the treatment and the error term, which means that certain people with certain unobservable characteristics are more likely to take the treatment or not. Now, if we want to think about this more systematically, and this is what they do here, again, we need a selection equation. And the selection equation here has 3 parts. So one is the main selection equation. And what they do is they say that the gains from treatment, alpha, have a heterogeneous component, as well as the costs of taking the treatment have a heterogeneous component. As well as, and then obviously if you plug alpha into here, alpha also has it varies across people in the population, and then respectively also in the sample. So this is the importance, the important extension of that the Bjerklund-Moffitt model offers. Okay, so it's no longer the case that whoever gets the treatment gets the same the same gain or loss in the outcome regardless of who they are, but the gain that people get depends on their unobserved characteristic, and depends in this case on the gains from treatment and the costs. That determines on whether they select into the treatment, and then also determines their outcome. So it's a slightly richer model. Now, one way to simplify this model is to take the reduced form, or to look at the reduced form. So what you do here basically is you take the treatment equation and substitute it. So you take the selection equation, let's call this 2, and you substitute that into the main equation 1. Okay, so you take D basically and substitute it in here, but obviously you also have to then substitute in alpha and phi. To analyze the Bjerklund-Moffitt model and to understand where the heterogeneous treatment effects are coming in here, it's best to look at the reduced form. So if we go back to the previous slide, what we're doing here is we're going to take the equation that governs the gains from the treatment and plug that into the main equation here. And then what we're getting is simply the first equation here. And obviously for people who did not take the treatment, that Z and U term are not present. And at the same time, we have a selection equation that is not only governed by the gains, which would be Z and U, but also by the costs, which is W and V. So what we're going to do now is we're going to look at various effects. That's what they do in the paper. And all I'm going to do here is I'm going to demonstrate how these effects can be expressed through parameters of the distributions of these various error terms. Remember again, what are those error terms? And the most important ones here are U and V. The gains from the treatment, they vary across people. That's U. The costs of taking the treatment also varies across people, and that's V. And then the gains in terms of the outcome are also related to the gains from treatment that you then see in the outcome are also related to the gains that people have from taking the treatment to begin with. Now, what we have here is, first of all, we are not going to look at the distribution of U and V separately, but we're just going to look at the distribution of the difference between the two. So that would be simply the standard deviation of that distribution. And because we have here two normal distributions, if we take the difference between the two, we end up again with a normal distribution. And now what we're doing is we can again look at the inverse Mills ratio here, which is simply with respect to U minus V. So again, think about that those two individual specific costs and gains as the following: Ui minus Yi. I will take the treatment if these costs, if obviously the gains are larger than the costs, and I will not take the treatment otherwise. And that's what's reflected here. So basically, my decision rule is based on the difference between those idiosyncratic factors. If that difference is greater than what you can see here in the numerator, that means that people either take the treatment or do not take the treatment. You'd have to work this out in what case you have which sign. Okay? And now and from that variable, we take now we know now that we can use, if we assume that this is normally distributed, then we can again use truncated normal distributions. What do we use those truncated normal distributions for? Well, we use them for quantifying some economically interesting effects. So for example, we want to know what is the expected gain from treatment for those who selected into the treatment. And so we're not here after the average outcome. So it's not the gain in terms of outcome. It's purely the gain in terms of getting the treatment or not. And so the expected gain from treatment is of those who selected into the treatment. Well, that's shown here by conditioning on for those people for whom di equals 1, and then conditional on those cost shifters. So cost and gains shifters. So what we do is here we take equation 3 here and simply take the expectation of that. And equation 3, let me see what it was. It's alpha equals Zi delta plus U. And so now I want to know what that is in expectation among those people who select into the treatment. And that's obviously something I don't know just by looking at the data. I need to make some assumptions about that idiosyncratic component U. And I can do that simply by, again, using truncated normal distributions. And that's what we have then here. And if we know or if we assume that the difference between those two idiosyncratic components is normally distributed, we can establish the inverse Mills ratio and we can compute that expectation. We know what that expectation is. Now, how to compute that, we can do this obviously in a tutorial, but what you can see here immediately is that the average gain from treatment among those people who have actually chosen the treatment is determined by the gain that comes from some instrument, but also depends on who are those people for whom selecting them into the treatment is most beneficial. So where in the distribution of the gains from treatment are they? Are they at the top or are they at the bottom? And that obviously then determines what is the average gain of those people. And now we go one step further from that, because that average gain by itself is probably not so informative. What we rather want to know is, well, suppose we manipulate the costs of choosing to get treated. Okay, the costs of getting the treatment, that is W. And so suppose we change W, then basically what we do here is we take the first derivative of that expression with respect to in that case W eta, which makes it all a lot easier. And all we're left with, and this is what they show in the paper, is again, we have a covariance that we know. We have the variance of that distribution of those two cost parameters, cost and gains parameters, and we have something related to the inverse Mills ratio here. So again, the average gain from taking the treatment here changes when we change the costs. And what they show here is that derivative is positive. So what does that mean? If you make whatever the treatment is, if you make it cheaper to get, you will see people taking the treatment with lower gains from treatment. Example, free childcare. If childcare initially cost you something, then you would see people taking childcare for whom the average gain was what equation 1 would give you. Now, if you make childcare cheaper or free, you reduce the cost, then by virtue of that positive sign is that this average will go down. So you will actually, the change will happen at the margin of people who are in the old regime were indifferent, but now all of a sudden free childcare or childcare pays off for them, whereas previously they were indifferent between using it and not using it. And so given that we change things at the margin with our policy, we actually hit those, or the behavioral change happens among those people with lower gains than the previous average. And that's one of the insights from marginal treatment effects that we will encounter over and over and over again. Now, I know that these formulae in themselves, they look strange when you see them for the first time, and they look a bit cumbersome to work with. But once you understand the concept, it actually comes quite natural to you. Trust me on that. Yeah, so again here, just to repeat, what we're doing here is equation 1, and let's call this equation 2. In equation 1, we say, well, among those people who've chosen the treatment, what is the average gain from the treatment? That in and of itself is not so informative. But what we do want to know is, in the entire distribution of the gains from treatment, for some people it's very beneficial, for others less so, and a lot of people are in the middle. If we change the policy by, for example, changing the costs from getting the treatment, how does that average change? And who are then the people who we actually who are the additional people that we shift into the treatment by changing that cost? Are these the people for who the treatment is most beneficial, or are these the people for who the treatment is least beneficial? Or are they somewhere closer to the those for who it is less beneficial, or closer to those at the top of the distribution? That's what these type of exercises tell us. And to my knowledge, Bjerklund and Moffitt were the first ones to do this systematically. And why is this so important? Well, it's important because it makes a connection between what we do in a typical policy evaluation and what we do in microtheory. Right? So in microtheory, when we try to establish what the effect of a policy is, well, we typically see that there are changes in behavior on the margin. And so there is obviously then those changes on the margin also affect some averages, but we typically see that a change in a given policy, if you have people who benefit more and benefit less from that policy, then there are some people who are exactly indifferent in whether they want to take a treatment or not. And if you give an incentive to people, then those who are changing their behavior are those who were initially indifferent. That some of those people who were indifferent would now be shifted into the treatment. That's typically what we see in a lot of microtheory. Changes happen at the margin, and marginal treatment effects uses this idea and puts that idea into an empirical framework that we can then use to study whatever effect we want and and to evaluate policies. So it's crucial. What is crucial to understand when you run your own IV analysis or even an experiment is you need to know who the instrument shifts into or out of treatment. And if you can pinpoint that group, you need to obviously tell us, well, is this an interesting group that we want to study? The big insight from Bjerklund and Moffitt is that we can actually quantify these effects that would otherwise be hard to quantify because of all these heterogeneities and these things we don't know, with parametric assumptions. So we assume something about the gains from taking the treatment, about the costs of taking the treatment, and by making distributional assumptions about these terms, we can actually estimate those quantities. Now, with this insight, we go back to the Roy model with potential outcomes, which is not part of the Bjerklund-Moffitt model. I mean, it's the mechanics of the Roy model are in there somewhere, but it's not explicitly stated. Whereas in what follows in this lecture, we're going to go back to this type of Roy model because that's what most of the modern methodology around marginal treatment effects is based on. Right? So here, what we have is we have the individual treatment effect delta I, which again is there is a common component to the treatment effect and an idiosyncratic gain. And so some people will gain a lot more from being treated and others not. And then we will revisit the question, well, if we have an estimator whereby you have imperfect compliance with the assignment of a treatment, or people genuinely select into a treatment, then what parameter does and should that estimator actually identify? In order to do that, we need 4, if not 5, parameters that we can or want to identify. The first one you have probably heard about, and you've definitely heard about earlier in this lecture, which is the average treatment effect. Now, how should we imagine the average treatment effect? So think about this as well, the average treatment effect in the entire population. Or in this case, the average treatment effect is the average across all the treatment effects of everyone whose x variable is at a given value. Okay, so think about x as being male or female, and then the average treatment effect for men is, well, the difference between the average across all the treatment effects for men. What is this average really, or what are those treatment effects? So think about it this way. You have a population of lots and lots of people, and you have a distribution within that population with respect to how effective the treatment is, or what gains or losses that treatment brings the individual. So there are some people who actually lose out when they get the treatment, and other people who gain a lot, and then lots of people in between. And so what the average treatment effect just tells you is, if you take the treatment effects across all the people in that population, it's just the average of that. So in other words, if you give the average person in the population the treatment, that's the gain in the outcome you should expect. Let me first then go to the local average treatment effect here at the bottom, because this is what we've talked about already earlier in lecture 3 when talking about instrumental variables. So that is the gain in the outcome among those units whose behavior has been changed by the instrument, right? Or who have been shifted into the treatment through the policy measure, if we don't want to talk about instruments. Okay, so that we've known before, and we've also seen that in an instrumental variable setting, that it's very often difficult to pinpoint who those compliers, those people whose behavior has been changed by the instrument or by the policy, is, who they actually are. That's very difficult. Difficult, but not impossible. And then we have two more treatment effect parameters that are also very important, and that we can or oftentimes cannot identify, but are often target parameters. That especially goes for the so-called average treatment effect on the treated. So what the average treatment effect on the treated tells us is, it's the average difference in outcomes between taking the treatment and not taking the treatment, so that the average gains from treatment among those people who have actually selected into the treatment. So again, think about a population where you line people up from the person with the lowest gain from treatment to the person with the highest gain from treatment. And then think that only those with a significant or sufficiently high gain from treatment actually take the treatment. Then the average treatment effect on the treated is the average treatment effect for those people. And if people selected into the treatment based on these gains, then the average treatment effect among those people who actually took the treatment inevitably has to be higher than among those people who did not select into treatment. And that would be the average treatment effect on the untreated. So this is sometimes a bit confusing to students to say, well, why should we be interested in the average treatment effect on the untreated if they didn't take the treatment? But they didn't take the treatment because it was probably not beneficial for them. Okay? And therefore, the average treatment effect on the untreated in itself is actually quite an important parameter, because what we have with imperfect compliance or with people who are able to select into and out of treatment is that the average treatment effect on the treated and on the untreated is different. And why is it different? Well, it's different, or to what extent is it different? It's different because those terms, those expectations are different. Again here, why are they different? Well, because those who select into the treatment, they come from a different part of the distribution of treatment effects than those people who do not select into treatment. Therefore, the two of them are different. Why is this important? Well, as I will show you in a later video, what we typically identify with a well thought out randomized experiment or exploiting a natural experiment that assigns something exogenously is the average treatment effect on the treated. But the average treatment effect on the treated is not what we should expect the treatment effect to be when we want to extrapolate to other groups. And because right now the people have chosen the treatment because it's beneficial for them and others not. And so if we then change the policy, we may get smaller treatment effects because now our policy expands to people for whom the treatment effect isn't so big to begin with, and who initially without the policy wouldn't have even chosen the treatment. And that is a crucial insight. So if I observe with my policy right now that free childcare in the current regime is highly beneficial for people in a lot of dimensions, I should not extrapolate that it would be equally beneficial if only I could nudge those people who currently haven't chosen to have free childcare but who have children. If only I could nudge those to actually take it up, to actually send their children to childcare. I should not expect these effects to be as high because there is probably a reason why on average those people have chosen not to send their child to childcare. And if I make childcare free, probably that obviously brings a lot more people to send their kids to childcare, but probably not. We should not expect the same returns to childcare as for those people who already sent their children without that policy. So and that's why the average treatment effect on treated and untreated are such important parameters. However, it's not necessarily said that the average treatment effect or the average treatment effect on the treated, which is what in most academic applications we are after, are actually those that are the most policy relevant ones. And why are they not so policy relevant? Well, again, because they implicitly assume that the individuals cannot really choose whether to take the treatment. So they basically just take the average treatment effect of some population and say, okay, this group in the population takes the treatment, that group does not take the treatment. Or in the average treatment effect, everyone takes the treatment. So the average treatment effect gives us the effect if all individuals were forced to take the treatment relative to no one being forced to take the treatment. If I take the average, then that's the average treatment effect. The average treatment effect on the treated you can see as basically you take those who've chosen the treatment and hypothetically you force them not to take the treatment, and the difference you see in outcomes is the average treatment effect on the treated. So in other words, this is very far away from a policy application, right? So imagine at the moment you have people who send their child to childcare, that's the treatment, that was their choice. And now to get to the average treatment effect on the treated, if you wanted to look at that parameter and quantify it, you'd have to force all those parents who currently send their child to childcare to not send them to childcare. And then the difference in outcomes that you see then, if you force them, that's the average treatment effect on the treated. Again, no policy works that way. Right? And then the equivalent for the average treatment effect on the untreated would be the opposite. Right? So you observe those people who currently don't send their children to childcare, and you would, and who have chosen not to do so, and you will get to the average treatment effect on the untreated if you forced all of them to send their kids to childcare and then measured the average difference in outcomes before and after. These are obviously hypothetical scenarios that you will not encounter. But the point here is that these effects are not typically consistent with actual policy changes. Right? So what we typically do is we give some people an incentive. We change the costs or the gains from taking the treatment. And that way, we change the behavior of some people. But we don't change the behavior to that degree that everyone who previously chose not to take the treatment all of a sudden takes it. Or that everyone who currently takes the treatment would not take it, which would help us to get at the average treatment effect on the treated. So this is very, very important. As much as it's important to think about these parameters as a benchmark, and I will also show you applications in the live lectures where some of these parameters are actually very informative, but they oftentimes are not. So what can we do instead? And we can look at a treatment effect that is policy relevant. And guess what it's called? It's called a policy relevant treatment effect. The idea is here, it goes back to Heckman and Whitlasil, to think about a policy change that then affects the propensity of people to take the treatment and changes who selects into treatment. And so what we want to study here is what is the treatment choice under a baseline policy and under an alternative policy. But these baseline and alternative policies should be real alternatives. Now going back to these parameters, here let's say the baseline policy is childcare costs what it costs, and the alternative policy is we force everyone to send their children to childcare and just make it mandatory. And then we get at one of those parameters. Here, what they argue for is, well, choose a realistic alternative policy, right? So go and take your child care policy from whatever it costs now to free or to a lower cost or a higher cost, or give people otherwise a reward for sending their kid to childcare. If that's what and then let's think, who does this alternative policy relative to the baseline shift into choosing the treatment? And then what is the treatment effect for that group that is shifted into the treatment? So this is related to a local average treatment effect, but it's a more intentional way of assigning the treatment, because here it's not that we just assign a treatment randomly and then we see who selects into the treatment or not, and we don't know who those compliers are, but we should have a better idea here, even though we can't know it fully, but we should have a better idea of who gets shifted into or out of treatment by moving from the baseline policy to the alternative policy. And so that's what the policy relevant treatment effect tells us. It's basically like you can see here, it's a Wald estimator. So the idea here is that the change in the policy shifts people into or out of treatment, and that also then affects the average outcomes. And so what our policy relevant treatment effect measures again is the component that is common to everyone plus the gain or loss, as in the mean effect per net person shifted into or out of treatment by the policy. Okay, so if it's monotonous that it only shifts people into treatment or only shifts people out of treatment, then it's simply the mean gain for every person who has been shifted into the treatment or who has been shifted out of the treatment by that policy. And so thinking about the treatment effects more in terms of alternative feasible policies is obviously a lot closer to what economists who evaluate policies should actually be doing. Now, one caveat here is that we may not always be able to identify the policy relevant treatment effect. Maybe the best thing we can identify is actually the average treatment effect on the treated. But then at least what we should do is we have to take a stand on, well, what is the policy relevant treatment effect? What is the relevant population that is getting shifted into and out of the treatment? And how different are those two effects? And can we learn something about the policy relevant treatment effect from whatever treatment effect we are able to identify? Another thing that's important here is that obviously if the treatment effects are homogeneous in the population, if they're the same for everyone, then trivially those 5 parameters coincide. However, that is not a good assumption. Typically, treatment effects vary a lot in the population. And if that's the case, we have obviously these parameters are not the same. Right? And also, obviously, if there is no systematic selection into treatment, let's say you have a random assignment of an incentive to get treated, such as a voucher, and if it's then random who actually takes up the treatment or not, then those 5 parameters coincide as well. But that is typically not the case. Right? So typically, as economists, we believe people to a great degree make their actions and their choices deliberately. And as such, there is probably a difference between those people who choose to get treated and those who don't.